Okay, so today when you do your homework, it's going to be weird. You're going to have really one question to do, and then the rest is all review. So you'll do the meat of your homework tomorrow. So we're going to do some pre-planning in class today, some pre-practice, and then you'll mostly do a review. So look at this quote review. It's really not a review. It talks about the following important vocabulary that you've got to get straight in your head. What an included angle is and what an included side is. You have to visually be able to identify an included angle and an included side. So as I'm looking at side AB and side CA, so here's AB and here's CA. If I were to take two pens that anchor those sides together, what's the angle that is in between or is created by those two sides? The angle. The angle that's created, isn't it A? Right? So in that hinge is that angle A. So your included angle is angle A. It's what is created by those hinge sides. Then we have an included side that would be between two angles. So if you put your fingers between angle A and angle C, aren't they naming the side that's between them? What side is that? CA or AC? So then you name these, and then we'll see how much of that you actually understand. Bless you. Is there a pattern that you notice that can help you? What's your pattern? Well, like for instance, with the included angles. So like on side BC and side CA, what's your pattern? Yeah, if a letter's repeated, so in this case, isn't the C repeated? That's your included angle, and if you look at BC, there's BC, and then CA, there's CA. There's where the hinge is. The angle is right there in between the hinge. So I really don't even need a diagram to see what that included angle is. And the included side should be fairly simple as well. Don't you just name the angles as the side? Right? Right. So then they have formally defined for you what a postulate is. A postulate is just a statement that doesn't have a formal proof behind it. We accept it as true without knowing that it's proven true. Essentially, we know we could prove it, but it just doesn't have a formal proof behind it. So underline the correct word. You can use properties, postulates, and previously proven theorems as what? Reasons or statements of proof? Reasons. And you might want to put on here and definitions. So you ought to be able to answer the question number 3. What's a postulate? A, B, or C? C, it's exactly what they stated above, right? All right, so let's actually get into the important part of today's lesson, and those are the 2 postulates that we're going to learn today to shorten up our proof work. So instead of proving all 6 sides congruent, we have learned that if we can prove 3 corresponding sides congruent, then we don't have to worry about the interior angles. Think about it this way, if I gave you 3 toothpicks, all the same length, and I gave you another set of 3 toothpicks, all the same length, wouldn't you be able to make the same triangle when you can't change how the triangle is made? This triangle is going to go together exactly the same. You can't make the angles different angles. Right? I can't make this go out bigger because then it's not going to close. So I can't make these angles bigger. I can't make them smaller because then the sides of the angles or the sides are going to overlap with each other. So if I had 3 sides that are exactly equal, there's only one triangle you can make. There's not multiples. So we have learned that we don't have to worry about the angles. So very important. Now I only have to prove 3 sides congruent, and you'll put to the side on your proof SSS or SSS postulate. And so your reason for proving the triangle is congruent would be your SSS postulate. So over here, this would be S, this would be S. These would be things you would put in your proof, and you might have reasons associated with it. It might be given, it might be the reflexive property, it might be something else. AC is congruent to what? DF, because they both have the 3 tick marks. And so that's your third S. Once you hit SSS, then you can say the triangles are congruent. You have to line up corresponding angles. So what angle corresponds to A? And note that A is in between the sides, because these might be oriented differently. A is in between the side lengths that are tick marked 1 and 3. What angle is in between the tick marks 1 and 3? D. So they do have this oriented correctly. And then B corresponds to E. It's between tick marks 1 and 2. And that leaves F. Y, this would be by the SSS postulate. That would be a reason in the proof. So let's look at a mini proof. They've given you all the reasons down below here, and you have to fill in some of the steps. They've given you partial steps. But let's look to see what they gave us. And immediately, when I'm doing a proof, I'm going to mark up whether they've given me sides or angles. There should be 0 heads on a desk. So this right here are congruent what? Sides. So there's an S. And they are tick marked. If they weren't, you would tick mark them yourself. They are tick marked with single tick marks. You can only tick mark things with single tick marks that all have the same measure. So then you have to use a different tick mark set of tick marks for things that are different measures. And then CD is congruent to FD is what? Side or angle. Those are sides, so I have SS so far. And then what else can you prove in here? Because we only have 2 things. We need now 3. So BD. So I'm going to triple tick mark BD. So the third thing is BD is congruent to BD. This is my pre-proof planning. Why? This would be the reflexive property. And then this is going to give me my third what? S. So now I have SSS. Immediately I can prove that the triangles are congruent. So that's what I'm looking to do in my pre-proof planning. I'm trying to find that SSS. And so that's what question 5 and 6 are trying to get you through. So we're going to complete the steps. So BC is congruent to what? BF. And I would not have separated these into different given statements. I would have put them together in one statement. But off to the side, this is the reason why they did it, is S. Because you want that progression SSS. And then, so we've used this one, so I'm going to cross it off. And then CD is congruent to FD. Cross that off, and that's my second SY given. Then my third is right here, which we came up with. BD is congruent to BD, and that gives us our third S. And we had reflexive property of congruent. What are we going to add here? Segments. Close. And then immediately upon hitting the SSS, that third piece, you can immediately prove the triangles are congruent by SSS postulate. So BCD, so B corresponds, notice that B is in between 1 and 3. So on the other triangle, what angle is in between 1 and 3? Tick marks 1 and tick marks 3. B, so we've got triangle B. Then C is in between tick marks 1 and 2. What's in between tick marks 1 and 2 here? F. And that leaves us with D. So there's only one right way to write the triangle congruent statement, and it needs to be exactly how they wrote it, and they should write it with corresponding angles to each other, which they did. That's it. That's one of your proofs. Is that difficult? That's far easier than what you had on that question 44 from last night's, right?
You just write SSS postulate, let's write that.
That's it. SSS postulate. You're not going to write the whole thing out. Because for that, I'm totally fine with it. Any other questions on that? Okay. So then we have a second postulate that's going to cut down our work, and it's called the SAS postulate for side angle side. The reason why we went through included angle, included side was for this particular one right here. It must go in the order SAS. Now your book may not go in that progression. I always will. And so this implies right here, this angle right here implies an included angle. In other words, it's got to be side angle side. That angle is the included angle in between the two sides. If you don't have the included angle in between two sides, you have side-side angle, which is SSA, or spelled backwards, a very bad word. Your backside that you sit on. So if you spell the backside that you sit on, ass, you've done an incorrect proof. You cannot prove triangles congruent by SSA or ASS. You have to have an included angle between two sides. So if you use bad words, forwards or backwards, then it's not a proper proof. Look at the diagrams that they've given you here. They've given you 3 different triangles, not oriented correctly. So notice that this triangle, the left side has 2 tick marks, but the left side here has 3. This is actually a reflection of this one, isn't it? And then this one has been turned, and this one has 2 sides that are tick marked at an angle that's marked. This has 2 sides that are tick marked in the angle, and this side has 3. So number 8, out of those 3 pictures, you can prove that triangle DEF, that's this one here, is congruent by SAS. So side angle side. Notice that this is the included angle, isn't it? In between this side and this side. Wouldn't you agree? So it must be a 3 tick mark and a 1 tick mark. So which of these 2 has an angle marked and 3 tick marks and 1 tick mark for the sides? Yeah, this one right here. What's the included angle here? T. So you can order the letters based upon that. So I know that D and T correspond. So here's D right here. D and T correspond, so I'm going to put triangle T. Then look at E. E is in between on this triangle, triple tick mark and a single tick mark. Oh, I'm sorry, thank you. Triple tick mark and a double tick mark. This just has a triple and a single, but won't this end up being the double tick mark? Because if these 2 are congruent, this is the only side left over that's going to end up being a double tick mark. So what angle is in between, because I'm trying to correlate it to the corresponding angle to E. E is in between double and triple. So what's between double and triple? R. So R has to come next. And that leaves us with T. S. I'll get there eventually. So if you're, and typically that's how I'll test you. I'll give you half of the triangle congruent statement. You have to come up with the other half because there's only one answer, right? Otherwise, there could be, I don't know, I think there are 6 different answers. I don't want to grade 6 different answers. All right, so you do number 9. But this one's by SSS. So you want 3 sides that are congruent and 3 sides that are congruent. You can't use my blue tick marks that tick marks here. You have to go with the original that was given. So if the original doesn't have 3 sides tick marked, you can't use that triangle. Hint, hint, hint. So does that mean that we're using these 2 triangles right there? Are they oriented correctly? No. And oftentimes what you'll see me do is I will cross this out and I will redraw it so that I want the side that's double tick marked here. So this side is double tick marked, so that means that F goes here and E goes up here. So there's my double. And then I want this side to be triple tick marked, which is D and E. Well, E's up here, so then D's down here. There's my triple tick mark. And then that must mean that this is still single. And now I can see the corresponding angles. So A corresponds to F, so triangle F. B corresponds to E, and that leaves us with D. And you could have done the same thing here, by the way. I could have oriented this one to this one by turning it as well, so that it's the same as this one. So any questions on that? Okay, so we're going to leave this part to do tomorrow, so don't lose this. And take out your workbook, and let's look at a couple of pieces. You're going to encounter some of the following that we're going to do here on tomorrow's homework, but I want to get it out of the way now. So the first thing I want you to do is turn to page 94. And I want you to look at the Think About Plan page, page 94. So one of the things I want you to do is use the distance formula to determine, you might want some graph paper. Most of these I want you to graph it so you can see what you got. To determine whether triangle ABC and DEF are congruent and justify your answer. So I'm going to take my graph paper here, and I'm going to plot the points to see what I have. So I'm going to plot the points for ABC. So A is 1, 4. And label your points. B is 5, 5. Everybody should be plotting with me. This is a participation class, not an observation. And then C is 2, 2. And then we're going to connect. And the reason why I plot them is it gives you a visual representation of what you've got, so you can see and try to determine what sides correspond to each other, and then what angles would. And if any of my lines are perfectly vertical or perfectly horizontal, everybody should be plotting. Everybody should have paper out. Even if you have notebook paper as a last resort, you should be graphing. And I'm going to plot D, E, and F. So D is -5. +1, and E is -1, 0, and F is -4, +3. So do the triangles appear as if they could be congruent? You're plotting? But are they oriented correctly? No. And we can only make the assumption, really, that FD and AC might be congruent. I don't know whether FE is congruent to BE or BC. Or, I'm sorry, BA or BC. And as a result, I don't know what angles correspond either. So, in the coordinate grid, what postulate can I use to prove the triangle is congruent? SSS, side, 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 or SAS, side, angle, side? Do I have any ability to figure out angles? No. The only way I have an ability to figure out angles is with perpendicular lines. So I have no ability to find angles. Or if I have parallel lines with a transversal, but I don't have that. So my only hope is SSS, the distance formula. The problem, the issue of the problem like this is how many sides do we have total? 6. So you're only going to have a couple problems like this on your homework because you have to do the distance formula how many times? 6 times. So one of the reasons why I plotted it was in the hopes that I would have vertical or horizontal lines. Because then I would just count squares, but I don't have that. So we're going to take a few minutes and we're going to do the distance formula. So I'm going to do the first 2 with you, and you do the other 4 on your own. So from right here, we're going to do the distance formula. So I'm going to start with, and I'm going to start with the sides that I think are congruent. So I'm going to start with FD and AC. And I'm going to find the distance from F to D. So I'm going to sub-note that as the distance sub FD so that I can remember what I'm finding the distance of. And the distance formula, if you forget, is listed all the way down here. But you're supposed to know that by now. So I'm going to draw my template. And then there's a minus in between there. And it might be helpful if I look at my ordered pairs here, right? It'd be nice if I had labeled my ordered pairs here too. You could do either or. So if I'm doing F and D, I'm looking at these. So I'm going to put those in my formula. So my y's are 3 and 1, so 3 minus 1. My x's are -4 and -5, so -4 minus and -5. That's why you put in your template so that you have a minus-minus situation. Take care of any double negatives, and you might want to do a plus-minus. It depends on the situation. That one you probably wouldn't have wanted to. And then we end up with 3 minus 1 is 2 squared, not -4 squared, plus, what's -4 and +5? 1 squared, which equals 2 squared is 4, plus 1 squared is 1. Isn't that the square root of 5? Now when you're doing these, I don't require you to simplify the radical. I want you to look at, in other words, if it were the square root of 45, we could pull out a 9 and take the square root of that. I don't want you doing that because you want to be able to compare what's underneath the radical. So here's this one, tick mark 1. What do we think the corresponding side to that is? AC. So I'm next going to find the distance from A to C. Doing exactly the same thing. And so AC are these 2 points here. So my y's are 2 and 4. And my x's are 2 and 1. And so if I add the opposite, plus and minus, I end up with 2 plus a -4 is -2 squared, plus 2 plus a -1 or 2 minus 1 is again 1 squared, and don't we end up with -2 squared is +4, plus 1, don't we get the square root of 5? So those agree, and so I can single tick mark that. Then you got 4 more. So I want you to find the distance of all 4 sides. You can do that in 2 or 3 minutes. Go for it. So I've gone ahead and finished the distance formulas for you, but if you're given this question, you have to be able to prove in that coordinate grid that all 6 corresponding sides, so all 3 pairs of corresponding sides are congruent. So when they give you a question in the coordinate grid, which you will have on tomorrow's homework, you have to show all that work or you don't get credit for it. You can't just say yes and look at it. You have to have the work supporting it, and I have proven that there are 3 sets of congruent sides via that distance formula. So work on tonight's homework. The first question is a proof. So I want you to make your best effort on that proof without actually looking at the answers to the proof. The rest of the homework is all review.